A series of seismic measurements were taken before and after a major earthquake. And we can see these measurements here. Note that these would be quite difficult to map just on an ordinary scale, because this one here at 10 to the 4 is 1,000 times bigger than this one, and 10,000 times bigger than the 10 to the 0 ones. So on a non-logarithmic scale, they'd be difficult to plot. But using the Richter scale, which of course is logarithmic, we'll get a reasonable graph of this, and then all you'd need to do is interpret that graph. So we're going to need the Richter values, and so for the first one, which is 2 times 10 to the 1, what we're going to have is log of, so we've got 2 times 10 to the 1, or just 20, and that is divided by 0.001. And what does that give us? That gives us 4.3. So that is going to go at 4.3 on our scale. And I just paused recording and put the other values in. Okay, so what we need to do is plot those on this graph. Now we're told that this starts at 0900, and so every quarter of an hour is each little dash on the axis. So our first reading is at 9:30, and it is 4.3, which is about there. Then the next one's at 10:15, and that is 3.5. We then get one at 10:30, which is the major quake at 7.7. So that is up here. And then at 10:45, so that's another 15 minutes on, we get an aftershock here of 4.5. And then at 11, we get a value of 4. It's just there. And then finally, at 11:30, there's another shock measured at 3.7, which is about there. And so you can see how they all fit very nicely on a logarithmic scale. As we mentioned, this one's sort of 10,000 times this one on a non-logarithmic scale, and then it's very difficult to plot. But on a logarithmic scale, they all fit very nicely. You just need to be able to interpret the scale